Hi, we are Group 41 from TO5, and today we will be proposing to you a deep learning model that we have designed and trained over the course of this project, which will provide valuable insight into the classification of the quality of wine. We believe that this model would be an important process in the manufacturing of wine, as it provides a scalable and objective method to determine the quality of wine comparing to traditional method of manual wine testing. We will now briefly go through our dataset and the notable details of our dataset. This dataset contains only physiochemical attributes and no label regarding the wine brand or origin. After doing data exploration, we have found that the distribution of our dataset is highly imbalanced and the distribution of each feature is not normalized. Here you can see the method that we have experimented with to balance the dataset. We use two methods which are combining new data from our dataset into current dataset, which we have already done prior the loading dataset, as well as naive upsampling and downsampling method. We also experiment with using synthetic minority oversampling techniques mode, but found that even after adding new data into our dataset, there was still insufficient minority data point to generate a meaningful set of data using SMODE. Therefore, we used the naive upsampling method in the end. We found that using the naive upsampling method managed to achieve a better convergence rate for our model compared to SMODE. In order to normalize the distribution of each data, we apply a log function to our feature. I will now pass my time to Taka, who will show you the graph and demonstrate his model.
Okay, so for my model, I have used the same pre-processing method as mentioned before. The difference is that I use standard scalar and naive upsampling and downsampling. So as you can see, our class distribution is very imbalanced. And to address the class imbalance in our dataset, we use naive upsampling and downsampling methods. So this is the code. The upsampling involves randomly duplicating the minority class data points to increase their representation in the training set. And downsampling is to randomly deleting the data from the majority classes to balance the data set. So after the downsampling, this is what we got. And the primary reason for using these methods is to prevent our model from becoming overly reliant on the majority classes, thereby helping it to converge and make reliable predictions across all classes. But however, there's a downside of using this method. So by duplicating the minority classes, the minority data points, we have lowered the quality of our data due to over-representation of these duplicates. So you can see that we have a lot of duplicates here. And similarly, a random decision during the downsampling might lead to a loss of valuable information from the majority classes. And we also use here. So we use the standard scalar for feature scaling. Ensuring that our data has a mean of 0 and a standard deviation of 1. So this scaling helps our model converge more quickly and perform more reliably by standardizing the range of our features. So we have already trained our model. So next, we'll test our model using the full dataset here. Okay, so we tested our model using the full dataset and the accuracy results 82.78 shows that our model performed well across different wine quality scores. And additionally, we also test our model using wine quality scores of 7 and 8 only. Let's run the code. Okay, so the accuracy results show that our model is very reliable when predicting high quality wine. The accuracy of 96.5. Okay, now let's move on to live demonstration. We have pre-processed the data beforehand to save time. So this is the data input. So, but in real-world applications, the user will input their data directly into the model, and the model will handle the pre-processing. So using the input I have just shown, our model predicts the wine quality to be 8 with a confidence level of 96.79. Yeah. So this is the second live testing. We also have this input, pre-process input. And we run the code, and the model predict the class to be 5 and the wine quality to be 5 with a confidence level of 91.40. Yeah. The live testing demonstrates not only the efficiency of our model, but also its practical application in predicting wine quality based on the given data. And now I will hand it over to Ellie to continue the next part of our presentation. Thank you.
We compare our deep learning model to other models like K-nearest neighbor, random forest, and support vendor machine. As you can see, here is the K-nearest neighbor, and K-nearest neighbor achieved an accuracy of 75.3% accuracy. And here's for the random forest. Random forest achieved an accuracy of 87.9%. And for the last but not least, support vendor machine achieved an accuracy of 91.9%. So for our conclusion, even though the K-nearest neighbor, random forest, and support vendor machine model achieve a higher accuracy than our deep learning model, our neural network still managed to achieve an accuracy of 84.21%. We believe that our model is satisfactory to our standard of achieving our problem statement. To design a neural network that can be reliable, predict the quality of wine, because our model is able to achieve an accuracy that is so close to the other models, as well as being scalable when our data become more complex in the future. Thank you.